There's one particular React warning we've been seeing in the console since we started building lists. It says that for each child in a list, you need to specify a unique key prop. This error is referring to app.jsx, but the same issue is happening in our songs list. Failing to specify a key can lead to unpredictable bugs. Let me show you what I mean. If you edit two list items and try to swap them while they're still active, it's not going to work. Also, if you try to delete this item while it's active, you see that the one below it disappears instead. The solution is simple. We need to add a key prop on each list item and give it a value that uniquely represents the item as React suggests. In our case, we can use the song ID because it uniquely identifies each song. Now everything works correctly. However, it's even more interesting to see why the problems happened in the first place, because this will give us more insight into how the virtual DOM works. So I'll remove the key for the moment. Let's start by looking at the virtual DOM before clicking edit, and focus our attention on the list items and their content. When we edit the fourth song, setActiveSongs gets called, which performs a state update, and thus a re-render of the list component and all its children. So React starts comparing the current virtual DOM with the new one. It compares element by element, and they are the same until the fourth list item. The contents of this list item have changed. Before it contained a div, and now it contains an input. Since the elements are of different types, React DOM will tear down the div and all its children, and replace it with the input. When we start editing the following song, it does the same. Then, when you try to delete the fourth song, the interface becomes inconsistent. So what's happening here? When we call setActiveSongs, again, the old state which included Brian Eno on ending is replaced with a new state without this song. This again triggers a re-render, and React starts comparing the current virtual DOM with a new one. It compares element by element. They are the same again up to the fourth element, but this time the type of the element has not changed. It's still an input. And since it hasn't changed, it doesn't get torn down as before. The only difference between the old input and the new one is its default value. In the new version, React changes the default value from Brian Eno on ending to global communication and leaves everything else the same. It then goes through with the rest of the elements. The next element used to be an input and is now a div, so it gets torn down and replaced. Then, the following element is a div in both versions of the virtual DOM, but has a different text content, so the text content will be changed from Robert Rich, distant traveler, to Steve Roden, forms of paper. It continues like this with the next elements. And it then finally reaches the last element, which doesn't exist in the new version of the virtual DOM, so it gets removed. We now have the new virtual DOM, which React DOM renders in the browser. But as you've seen, the interface is inconsistent, and that's because the only thing that changed for the fourth song was the default value. Default value is, as the name suggests, the default value an input receives when it first appears on the page. But since our input is the same input from the previous render, changing its default value doesn't have any effect. This is obviously not what we wanted. Everything started going wrong when we reached the fourth element in the virtual DOM comparison. Since React compares the elements one by one, it can determine that this element was deleted. It just compares it to the element at the same position in the new virtual DOM. And this is where keys can help. A key identifies an element, and if you don't provide any, then React sets the default key to be the position of the element in the list. But since elements can change positions, a position does not uniquely identify an element. What we need is a stable identity that uniquely identifies the elements, And we can use the song ID here because no other song has the same ID. So let's see what happens if we add the key back. When we call setActiveSongs, again, the old state is compared with the new state. This triggers a re-render. And React starts comparing the two versions of the virtual DOM. But now, when we reach the Brian Eno list item, you can see there's no corresponding list item in the new virtual DOM with the same key. This means that the element was deleted, and React can continue looking at the next one. The next one is the same, and so are all the others. So it knows now that it's not supposed to change the default value of the fourth element, but rather that it needs to remove it from the DOM. It also knows that it doesn't need to change all the elements that follow the Brian Eno item, like it did before, so it's more efficient as well. A good key has two attributes. It's stable across re-renders, and it's unique among its siblings. This excludes array indexes and randomly generated keys, because neither of them is stable. In contrast, database fields like unique identifiers obtained from the server's data are ideal choices for keys.